Let's get started. Good afternoon, everyone. Thanks for coming to this session. My name is Charlie Wen. I'm a program manager on Azure networking team. This session is about ExpressRoute, Azure ExpressRoute. I break the session into 3 parts. I'll start with the overview. Basically, if you are not familiar with ExpressRoute, I hope I can bring you up to speed to what we have done in the past few years in a few minutes. Let's see how it goes. And then we'll take a close look at the new features we have introduced, we have added for the past year. And then last but not least, I'll talk about some best practices. I'll talk about some design patterns. I'll talk about cloud to cloud, which becomes, many of you adopting multiple cloud. And I'll give you insights how you can implement cloud to cloud. And actually, I'll also talk about DR, disaster recovery. So I'll start with some basics, which is how you connect to Azure, how you connect to our services. The majority of you and most of the traffic will come to us over the public internet. That shouldn't be any surprise because internet is really everywhere. It's easy to set up. So and our network actually is connected to the internet. So as long as you have internet connectivity, you can connect to our network, and you can connect to our data center and all the Azure services running in our data center. Alternatively, you can also work with the same service provider to set up a private connection to our network. So this private connection bypasses the internet. So in terms of performance, the latency is more consistent. You'll see less jittery, and you'll see less packet loss. So for the application, for your user experience, usually it's better. We also offer the SLA. I don't think the ISP usually offer, internet service provider offer. But I think the most important, put aside all these technical aspects, I think the most important thing is with a private connection, you know exactly who's between you, your network, and the Microsoft, right? So when you have a problem, you know exactly who to call. So I think that's something really, the feedback we received from the customer, I think that registered well with customers. One common question is, how does the service provider connect to Microsoft with this private connection? So this all happens in a place what we call ExpressRoute site. There are many misconceptions about ExpressRoute site, and one common misconception is ExpressRoute site is Azure DC, is Azure region. As you can see, this is a state of Virginia, and that's not the case. ExpressRoute sites and Azure DCs are physically apart. Azure DC region basically is where we put our compute and the storage and networking resources. And ExpressRoute site is in a public co-location. Basically, that's actually where we put our router, where service providers put their routers. So then we do we do cross-connect. And another trick is you can tell the difference by the name. ExpressRoute basically is named after city, like in this case, Washington, D.C., Washington, D.C. 2. And the Azure region is named after a country like the US or a geo like Europe, West Europe, North Europe. So this is a more detailed illustration of ExpressRoute. Some of you may see this picture before. The takeaway for you basically is 2 things. One, each ExpressRoute circuit has 2 connections, a primary connection and a secondary connection. So when we deploy our routers to ExpressRoute site, and we always deploy by pair, so when you create the ExpressRoute circuit, we make sure that the primary connection and the secondary connection are created on the primary router and the secondary router independently. So you have this built-in high availability. The second thing is you can see each ExpressRoute circuit supports 2 routing domains. That's what we call peering. We support Azure Private Peering, so that gives you access to Azure Virtual Network, right? Azure Virtual Network is you run your private IP address, you bring your own topology, you bring your own network security policy. So that basically is extension of your on-premise network. Microsoft peering, we give you access to all Azure PaaS services, Office 365, Dynamics 365. So that's when you come in, it's basically it's a Microsoft global routing table you share with other customers. So let's take a closer look at I talked a little bit about how service provider connect to us. So from customer point of view, from your point of view, so here are some connectivity models. So the left three models are what we call service provider models. For them, basically, these service providers are connected to Microsoft already. So when you create a circuit, this circuit will be created on the physical connection between the service provider and us and the Microsoft. And which model you choose really depends on where you are located, what service do you want from a service provider, like a layer 2 service versus a layer 3 service, and also depends on your topology, right? Do you want a point-to-point connection, or do you want a any-to-any, like an MPLS, IP VPN type of a connection? The right-hand side one is a new model we introduced last year. So what do we call? We call it ExpressRoute Direct. So with this model, you buy a 10 gig or 100 gig of physical port on our router, right? So you basically, you own your own provision, your own work experience. When you create ExpressRoute circuit, you don't need a service provider to provision for you because that circuit is automatically provisioned for you, right? Because you own this physical port. Now, this is a map of ExpressRoute sites. We are pretty much everywhere, as you can see. We are in 6 continents in 24 countries. And we've been making a lot, we've been expanding very aggressively. The red ones are fairly new. One thing you will notice, or you know, is we actually have a commitment. Every time you hear us announce a new Azure region, you can count on us having an ExpressRoute in that country, ExpressRoute site in that country. And this is the roadmap. As you can see, we are expanding to new countries like Thailand, like Colombia, I think there's another one, Mexico. And also one thing is we are also setting up a redundant ExpressRoute site in some metros. I think in the previous slide, I didn't mention, we already have 2 ExpressRoute sites in Washington, D.C., in London, in Singapore. And we continue to add additional sites in some of the bigger metros, like Toronto, like there's another one here, Sao Paulo in Brazil. So that will basically give you redundant connections to Microsoft data centers. And we'll talk about that in detail later. So these are our partners. We have a lot of logos here. ExpressRoute partners are critical to us. I would say without these partners, there won't be ExpressRoute. Simply, it's very simple. We don't have this last mile connectivity to the customer. So we rely on these partners to connect you to us. Now, if you have not heard of it, we have a new partner program. We call the Managed Partner Program. So the idea is, I will use ExpressRoute as an example. So today, if you provision ExpressRoute, you basically will work with the service provider to set up this point-to-point connection, MPLS connection, right? And then you also log on to Azure portal. You provision ExpressRoute circuit, virtual network, gateway. Now with this program, some of these providers basically can do this managed service for you. So they can do this end-to-end provision for you, not just the circuit, but also the VNet connection, virtual network, and so on and so forth. And you can see, actually, the program is actually fairly new. We launched the program in summer this year, but we already signed up on many partners. And we will continue to expand, and we're going to continue to sign up on new partners to give you this service. So that's very quickly, that's the overview. I'd like to spend more time on the new features and the best practices. If you have more questions about ExpressRoute, feel free to ask me after the session. So now let's look at the new features. So first, let's look at the, So let's look at this new enhancement we have made in the past year. FastPath basically is a feature designed to improve the data plane for performance for Azure Private Peering. So if you are familiar with Azure Private Peering, you know you actually have to set up a virtual network gateway, right? So that virtual network gateway is actually a software implementation. It's limited to 10 gig. So when we introduced the ExpressRoute 100 gig, we designed this FastPath. We want to make sure that if you have 100 gig, you can actually send 100 gig traffic to your virtual network. Now, for the past year, we learned this feature actually can benefit many customers as well. It's because for network performance, it's not just about throughput. It has other measurement, like the number of flows, right? The packet per second, connection per second. So now we actually make this feature available to every circuit, no matter whether it's a direct port or whether it's a service provider circuit. BFD is another feature. It's a bidirectional forwarding detection. It's a routing protocol. We actually introduced this one last year. We enabled this for some of the largest gaming companies, so they can reliably streaming their games. So even if there's a blip in the network connectivity, traffic can fail over quickly, because this protocol can fail over the traffic between the primary connection and the secondary connection on order of seconds, right? If without this one, you have to wait for up to 3 minutes. That's a default routing protocol if you don't have a BFD. So the next one is actually very, we are surprised, actually. This is actually very many customers are looking for this one, which is multiple circuits to the same VNet. There are two major scenarios. One is redundancy. So you want to have work with two service providers to have two circuits to connect to your virtual network. If one service provider has some issue, you still have connectivity. You can fail over to the other service provider. But the next one is also very interesting for migration. So let's say if you want to increase your circuit the bandwidth, or you want to decrease your circuit bandwidth, or you want to change the building type of your circuit. So now this feature will allow you to do this change seamlessly. So all you need to do is basically set up a new circuit, provision it, connect to your virtual network, and then decommission the older one. So you can do this seamlessly. So this multi-circuit from the same peering location to the same VNet is actually will be very helpful for some of you. BGP community is not new. What's new here is we actually added a new community support. So before, you can basically select all Azure private IPs from US East. But now you can basically say, I only want to receive the IPs, Azure storage IPs from US East. I only want to receive Cosmos DB private IPs from US West. So we give you this granularity. You can reduce the number of IPs you receive. We also improve the Azure Monitor. So now you can monitor the BGP session on your ExpressRoute circuit. So every time if there's a BGP session goes down, you can get an alert. You basically know something's wrong. You can take some action. We're very excited to announce we actually have a new SKU for you. So if you are familiar with ExpressRoute, you know we actually have two SKUs before. We have a standard, we have a premium. I'll use example. So if you have a standard circuit in Washington, D.C., that gives you access to all Azure regions in the US and in Canada, right? If you have a premium circuit, it gives you access to all Azure regions globally. Now with ExpressRoute Local, it will give you access to, in that case, give you access to US East and US East 2. So give you access to these specific regions. So you ask, what do you get in return? So what you get in return is basically we don't charge you for the data transfer. We don't charge you for the egress data transfer. So at the end of each month, you get a fixed bill. So that's actually, we heard from many customers, that's actually very helpful because everyone, many of them want to have a reliable building. Can you save the question at the end of the session, please? Thank you. Okay. So I'll leave this at the end. Sorry. Yeah. This is available on both the ExpressRoute Direct port and the service provider port. And one thing is, it's not available at all regions, right? So we basically, the name basically says it, it's a local. Basically, it means it's only available at the sites where there's a Azure region nearby. Example is Atlanta. We don't have an Azure region in Atlanta or in Georgia. So local is not available in Atlanta. You have to get a standard or premium. Now, you may have heard of this. Now, ExpressRoute is available for satellite users. So we partnered with 3 major satellite service providers, so they can offer this. So you saw our ecosystem, the list of partners. So these partners are giving us a good coverage, but we believe this program will actually take our coverage to the new level, because one example is if you are on a ship in the ocean, right? There's no other way to connect to us, but now the antenna on the ship can upload the data to the satellite, and the ground station basically will download this data. And these ground stations, from these provider, our partners are connected to Azure, over ExpressRoute. So now we can backhaul your traffic, we can connect you to any Azure region. Or we can even connect to your own branch, your own private DC using ExpressRoute Global Reach. We are seeing new scenarios that can benefit from this, this offering, like aviation, like remote farming, manufacturing, IoT. We're welcome because when we work on something like this, we always sign up multiple partners because we want to give you choices, right? And with these partners, you will see there's a difference in technologies, there's a difference in pricing, so you can decide what's best for you. One thing is, one thing I learned is when we were doing some validation, we found that even the lowest satellite is about 400 miles above the ground, 400 miles. So that means latency is higher than usual. So when if you have this service, make sure you expect higher latency and use the right tool to optimize this performance. So I give you an example here. So if you want to upload data to Azure storage, use AZ copy, because that tool is designed by our storage team. That basically open multiple connections, will optimize this kind of a scenario. Now, some of you may know, we have an Azure instance in China, right? So if you're a multinational company, you may have some deployment in China, some deployment in Azure global regions like US, Europe, or Japan. So one question is, how do you connect these together, right? So you can connect over the internet, but the internet quality is not good, right? So we are working with Chinese carriers to really to have a private connection for you. So now you basically can connect your virtual network in China to your virtual network in Singapore in this example. So all you need to do is to set up 2 ExpressRoute circuits here, one in Shanghai, one in Singapore, and China Mobile will basically give you this private connection. So we also announced new capabilities for virtual WAN. We had a session this morning. I'll just quickly go over the new capability. First, we enable routing between VPN and ExpressRoute. So now if you look at this picture, no matter how you connect to the VUN hub, you can basically enable this routing. We also enabled hub-to-hub transport. So if if the sites on the left hub can talk to the sites on the right hub, right? So give you this any-to-any connectivity. You can also use global reach to connect the 2 ExpressRoute sites in this example. Now we are very excited to announce this new feature because we believe we are the first one to introduce this new feature that will help us differentiate ExpressRoute from other products. This is MACsec encryption. So MACsec encryption is a point-to-point encryption. We enable this for our direct customers. The problem it is trying to address is if you are direct customers, right, your routers and our routers are in different places in ExpressRoute site, right? They could be on different floors, even in different buildings. Now with MACsec, you can basically encrypt the link, and then you can ensure the data confidentiality and integrity. So this is we are very excited about this feature. So if you are in the financial business, you are in public sector, you'll find that this feature is very useful for you to be compliant with your internal policy. Now, this is the encryption, right? MACsec is the encryption protocol, so it has a key. So we basically will allow you to bring your own key. So you put the key in your own key vault. We will not store the key in our storage table, right? So you basically, you manage the life cycle of this key. So that basically means you decide when to update the key and how frequently you want to update the key. Another nice thing we add is we also make sure that if there's a key mismatch, so basically the key on your router and the key on Microsoft router don't match, we basically will block the traffic. We basically will drop all connectivity. So basically we'll make sure you don't have to worry that a human misconfiguration, if some admin misconfigure the key, you don't have to worry that a misconfiguration will expose your confidential data on this link. Because if there's a mismatch, we just drop the connectivity. So when the key update, another thing I just want to mention is the key update on both sides is not atomic, right? So you have to update on one side and update on the other side. So basically, for a brief period of time, there's a key mismatch. So basically, we'll lose connectivity. So the key update is disruptive. So we highly recommend if you want to update the key, you basically schedule a maintenance window. Okay, so now I want to talk about best practice. And the number of topics I want to go over. The first one is ExpressRoute. I'll start with ExpressRoute Virtual Router because this is the key component, right? It's particularly for Azure private peering. You must create this virtual network. It is actually not just forwarding your traffic. It's also in the control plane. It will receive the routes from your on-prem, propagate to the virtual network, and also basically when you add an additional virtual network to the gateway, you will advertise these routes to your on-prem. So basically it's in the control plane and in the data plane. So there are two angles when you look at how you choose which gateway works for you. The first one basically is the deployment type, right? So each ExpressRoute gateway, the first one is what I call like a classic deployment. So each gateway has multiple VMs, right? So in the classic model, when you deploy this gateway, we basically will place these VMs in different DCs in the region. And the placement is not deterministic, right? And the second one is you put all these VMs in the gateway in the same AZ, in the same availability zone, right? So that you can say if your application, for example, if your application is in AZ2, you can say I want to put my gateway in AZ2 as well. So that basically will minimize the latency between your gateway and your application VMs. And the third type is what we call zone redundant gateway. So in this case, when you create the gateway, the VMs basically will make sure the gateways are placed in different AZs. So that basically gives you high availability, zone level, AZ level availability. So if one AZ goes down, you still have access to the virtual network, to the VMs in other zones. So there's another dimension. Another dimension basically is the VM size. So basically we have 3 VM sizes, small, medium, large. Depending on the deployment type, the SKU names are different. Classic, if you have a classic, it's a standard high-performance gateway and ultra-performance gateway. And for the other 2, you have an ER gateway 1, 2, 3. Now, to choose the right gateway size, there are a few things you should consider. Performance for sure. It's you choose the one to meet your throughput, connections per second, and all these requirements. We actually publish these numbers on our website, and you can just look at our document, look at the table, pick the right size. What we have not talked a lot about is the VM, the number of VMs in your virtual network, in the virtual networks behind the gateway. As I mentioned, this gateway it really plays a critical role in the control plane, right? If you have a lot of VMs in your virtual network, whenever there's an update from your on-prem, the gateway will need to push this update to your VMs, right? So if you have let's say if you have 1,000 VMs, then we recommend you to have ultra-perf gateway because that gateway has more CPUs in the VMs. They can handle more of these updates. Another thing is the features. Some features like a FastPath is only available on ultra-perf gateway and the AZ gateway 3. And you will see actually we'll innovate more in the gateway in the future, and we'll make more features available on gateway, and some features will only be available in certain SKUs. So the next topic is and the VPN coexistence. This is also I talked about this before, but it's a very common topic. It's very popular. The design goal basically is we want to give you a redundant connections to your virtual network, right? So when you have this setup, we put we have a ExpressRoute gateway and we have a VPN gateway. So basically there are two gateways we put on the gateway subnet. And when we do maintenance, we actually serve these gateways independently. So when we make sure that when we actually update gateway, your VPN gateway is still up and running. One thing is now you have two connections, your VPN connection, ExpressRoute connection. Now, which path will we take? That's a very common question for us. All you need to remember is two things. One is if the prefix, basically if the prefix is different, we basically will pick the one that has we pick the link that has the most specific prefix. So here, if I receive a /24 on the VPN connection and a /16 on the ER connection, then I'll basically send the traffic to you on this VPN connection. Now, if you send me the same prefix, then we always prefer ER. So basically, we hard-coded this. We always prefer ER. So it's very important. So now you know our logic. So it's very important for you to also to make sure you select the path for the traffic coming to Microsoft, right? Basically, you want to select the same link because we want to make sure you have a symmetrical routing. If you have asymmetrical routing, many times things can go wrong because for your VPN, you may actually have a different firewall, right? So symmetrical routing, make sure you select the same path for the traffic coming to Microsoft. Now, UDR is actually a very useful feature. One scenario basically is, let's say you want to basically set up a firewall. You want to send all the traffic from your on-prem to your applications through this firewall. Now, to achieve that, you have to configure UDR. You put this UDR on the gateway subnet. Now, but it can also cause some problem if you are not careful. For example, if you configure a default route, 0/0. Now, if you do that, basically, we'll break the gateway. It will break the gateway from talking to our controller. It will break the gateway from talking to each other. So for that reason, we now have an API. We basically will reject this UDR if your UDR has a 0/0. Now, we recommend you basically in this UDR, we recommend you to specify specifically which subnet you want to send the traffic to. So now I want to talk about ExpressRoute design patterns, specifically how you connect your VNets to ExpressRoute. The first one basically is you just create a big VNet, right? You basically put all your applications, all the VMs in this single VNet. Now, this is actually very quick to set up and very easy to manage. And also, if you're actually adopting multi-cloud, and you will find that this is basically a common denominator across all like cloud service providers. But the downside of this is you may actually, if you have a really large deployment, you may actually run into the subscription level resource limit because each VNet is owned by one subscription. So each subscription can only allow you to create a certain number of VMs, certain number of CPU cores, right? So that basically you may actually run into this problem. And also, if this is just a single VNet, so that limits your choices for security, right? You can only have that many choices for a single VNet. The second option is you put your workload, your production workload, your non-production workload, or your different BUs, different business units like your marketing, your IT, your R&D. You put all these in separate VNet, right? And then you connect all these VNets to the ExpressRoute circuit. The good thing about it is now each VNet is by itself is a security and compliance boundary, right? So you can set up different levels of access control, different levels of security. You can have this for each VNet. And there's no resource limit because these VNets, all these VNets could be in different subscription. So we support this case, right? ExpressRoute is in one subscription, VNets are in different subscriptions. So we support this scenario. But there's a downside for this deployment as well, for this design as well. First, we only, there's a limit on the ExpressRoute, there's a limit on how many VNets you can connect to an ExpressRoute circuit. So for a standard circuit, you can connect up to 10 VNets. These VNets basically are in the same, from the routing perspective, basically they are in the same routing domain. These VNets can talk to each other through this ExpressRoute. So but there's a downside, right? They can talk to each other, but the traffic will be routed out of our DC because ExpressRoute, our physical routers are at ExpressRoute site. So when a VNet sends traffic to another VNet, this traffic basically will take out the DC, go to the ExpressRoute site, and then come back. So there's a higher latency. So if your Azure region is away from the ExpressRoute site, you have a high latency. And also in terms of performance, the gateway, basically the traffic will go through the gateway, and your performance, VNet to VNet, will be limited by this gateway. Another type is what we call hub and spoke. So in this case, you put all your common services, common workload in a hub. You can enforce all the security policies, compliance policies in this hub. And then you basically put all other VNets as a spoke VNet pair with this hub VNet. So the advantage is now in terms of performance, there's a unlimited bandwidth throughput between the spoke VNet and the hub VNet because there's no gateway. The downside basically is over time, there's a lot of management overhead. Every time you need to maintain this hub and spoke model. So every time you add something, you have to do this VNet peering configuration. VNet peering configuration by itself is multiple clicks. And also, you have all these VNets, spoke VNets, right? And all these VNets basically are sharing the same gateway, right? So the gateway, again, could be a performance bottleneck, both in the data plane and also in the control plane. So there are two more design choices. One is, I call it like a full mesh. So in this case, basically, you have a gateway in each VNet. You connect each VNet to your circuit, right? And then you also set up a VNet peering between all these VNets. So this design basically give you the highest performance because VNet to VNet, you go over VNet peering, VNet to on-prem. So each VNet has a gateway. You go through the gateway and to your on-prem. So this design gives you the best performance. But the downside, again, is the overhead. Just imagine you try to add a new VNet here, and you have to set up the gateway, set up the connection to the ExpressRoute side, and also set up all the peering. So the last one basically is the what I call hybrid. So basically, for this one, there's no design principle here, honestly. You take whatever works for you. This is actually very common. It's very flexible. But the downside is it's not repeatable. It's hard to create a template for this kind of topology. You cannot repeat this in other regions. So my next topic is cloud to cloud. So we have seen many customers basically adopting many cloud. We fully respect your choice, for whatever reason. So I just want to give you some insights and just share with you how you can implement this cloud to cloud. So there are three scenarios. The first scenario basically is public to public. So the scenario basically is you run some Azure PaaS or SaaS services on one side, and you run some PaaS and SaaS services on the other CSP. So the question is how you let the services talk to each other. The good news is for this scenario, you don't have to do anything. The reason is all these PaaS and SaaS services are running on the public IPs, right? So from Azure's perspective, the PaaS services running on the other CSP are just like a part of the internet. So as long we always have internet connectivity, so there's no problem for the PaaS services on Azure connect to the PaaS or SaaS services run on the other CSP. And what's even better is I can share with you, we and the major CSPs are usually in the same co-location facility. So usually basically plug into the same, something called internet exchange. So basically these major CSPs are just one hop away from Microsoft from the routing perspective. So this is actually optimized for you. Not only you don't have to do anything, these connectivities has already been optimized for you. The second scenario is, this is a harder one. So basically, the scenario is you have a virtual network on Azure, you have a virtual network on the other CSP. How do you actually set up a private connection between these two virtual networks? So what you can do is to find a service provider that is common, provide common services to Microsoft and the other CSP. So once you find that there's a common CSP, the chance is very high they can do this for you, because what they can do is basically they just stitch these private connections together and provide routing between the two, right? So one thing basically I want to call out is you need to find a layer 3 service provider, because ExpressRoute basically requires you to set up a BGP, right? It's a layer 3 control protocol. So the service provider has to support the BGP. And also the service provider has to take care of some differences between our implementation and the other CSP's implementation. For example, we support up to 10,000 prefixes. The other service provider maybe not. So the service provider in the middle need to summarize these routes. So these are things, some details we need to work with the service provider to make sure they have a correct, proper implementation. Another choice, basically, you can also do it by yourself. You basically route the private connection to your on-prem. So again, there's pros and the cons. In terms of pros, if you have a private DC, your private DC or private network can participate. It can plug in this connection. You can have a 3-way communication. But that also depends on where your on-premise is. If your on-premise is pretty far away from us, then you will pay a latency penalty. The third one basically is private to public, right? So the scenario is you run Azure PaaS services, and then you also have a virtual network on the other CSP. How do you enable the virtual network on these other CSP to connect to Azure PaaS services? Or vice versa, actually. I just use this example. Vice versa is also true. So in this case, the same service provider I just mentioned can also do this. So what they need to do is, in this case, they also need to provide the NAS service for you, right? So on one side is private, on the other side is private, so public. So they need to translate the private IP address to public IP address. They need to provide this NAT. They also need to make sure they inject the public IPs into the customer's virtual network. Now, there's a better solution. The better solution is a private link, right? We just announced this new service here. The private link basically allow you to access the Azure PaaS services through a private endpoint. So the private endpoint basically is in your virtual network. So if you have a storage blob, your storage blob basically will have a private IP in your virtual network. And that private IP basically will be advertised to the other virtual network over ExpressRoute. So the VMs on the CSP will connect to Azure PaaS service through this private endpoint. So you have this private, using the same private connection to access Azure PaaS services. So my last topic is disaster recovery. So for a long time, Azure has this concept. Basically, it's paired Azure region. So US East, US West is a pair of a region, right? So it's good because these regions, paired regions, are at least 100 miles away from each other. So it's good to survive some natural disaster. If something happens, you can fail over to the other one. The problem is if you run some latency-sensitive application, let's say your main application, your main users on US East, but when you fail over this workload to US West, then basically your user experience will go down, right? Because there's a round trip between US East to US West. And we are seeing customers also adopting this new design, which is by taking advantage, which is to take advantage of availability zones. The availability zones, basically, each of the AZ is a fault domain by itself. They are 10 miles away from each other, roughly 10 miles away from each other. So if one AZ goes down, you fail over to the other AZ. So it doesn't impact your performance because all these AZ are in the same metro, right, in the same area. So that basically is very friendly for the latency-sensitive application. And this is also good if you have your own private DC or you use other CSP as a backup. So this is actually a very viable choice for you. So one example here is, let's take a more specific example. In this case, you have two regions, you have two ExpressRoute. We highly recommend you to set up these cross connections because if one side goes down, if one connection goes down, you basically can fail over to the other one. Once you have these multiple connections, of course, you have a more design. You need to design carefully. You basically need to decide which path to take. So we actually discussed this before. We also have a document. Basically, you can use the BGP attributes like a local preference or the AS path prepending to basically decide which path you want to choose for your outbound traffic and for your inbound traffic. Here's another example. So in this example, basically, you have two private data centers, right? You have your own backbone. Again, you have two Azure regions. Now, in this case, you have another choice. The choice is, do you want to use our Microsoft backbone, or do you want to use your own backbone, right? It's your choice. Now, if you want to use Microsoft backbone, you basically need to have a breakout at a local ExpressRoute site. So basically, let's say on the west side, on the West Coast, you send the traffic to break out the traffic to your circuit on the US West. And then basically, we'll use our backbone to connect you to your region on the US East. You can also use your own backbone. But whatever you do, you need to make sure that the return path, also the return traffic, also take the same path. Again, it's a symmetrical routing because if you don't have this symmetrical routing, you basically, in the long term, you will forget about it, you will run into trouble. You put some firewall there, the firewall will break your connectivity. So you want to make sure, no matter which backbone you choose, make sure you choose have a symmetrical routing. So the last one is actually another design choice. So you have your own backbone, you have your own on-prem, but you can always enable global reach as a backup. Now, in case you have a problem in your service provider's network, and the traffic basically will fall to Microsoft network, and basically will use our backbone to reach the other side. So again, this is some choices you can, implementation, you can think about it. So that's actually it. I know I have run really fast for this. I only have like 45 minutes. So if you have any questions, please stay and come to the stage. Happy to answer your questions. Thank you for coming.